Now students, this is a kit for verification of Ohm's law. That is, this has everything inbuilt. It is everything inbuilt there. So we can see there is an ammeter, there's a voltmeter. So the circuit is typically a bit different shown over here. So in this case, what is actually we are doing is here's a switch, here is a rheostat, you can see. Is also written over here, written in the wrong place though. Here's a rheostat, and if you just vary the pointer of this rheostat, that is, I just vary the knob, then what will happen? This rheostat, we will just vary the resistance, and there will be a current flow through this. Through this resistance. Okay. So if you just vary the rheostat, then there will be a different current flow through this resistance. So in this practical, what we are doing, we are actually varying the current flow. Okay. But in that practical, what I show you, the circuit diagram what I showed you earlier, in that case we are varying the voltmeter. Okay. So the EMF or potential difference across the resistance. So these are actually of two different kinds of circuit. What we can do is, and here, as I told you, if we just vary this resistance, the current will be varying through this, and what we will be doing is just measure the current through the ammeter here. Actually, it is written A over here. So here's a milliammeter what we are going to use, and here's a voltmeter, and this voltmeter has a range up to 6. We can measure up to 6 volts. Sorry for the blurred image. Okay, we can measure up to 6 volts here, and as we can see that each, here from 0 to 1 volt there are 10 divisions. Okay, so actually we are going to measure 1 by 10, that is 0.1 volt by each division. So each division over here will give me a reading of 0.1 volts. So this is the least count of this voltmeter. What is the least count? Least count is actually the minimum count, the minimum value what we can measure by using an instrument. Okay. As you can, you have already learned this in class 11 in what is least count, and so that's it. Now this circuit is have everything inbuilt, and this resistance is not connected over here. So what I have in my hand is a resistance. It is having a value of I guess 10 ohms, 5 watt. It is written that it is actually fusible resistance. So if you have a larger current flowing through this resistance, it will actually get fused. Okay, means it will just blow off. It will not burst over here like this. It will just not work anymore. So that's a fusible resistance. So this resistance is in my hand, which I will connect over here. Okay. Actually, the previous instrument was having some problems, so I have changed this instrument, and here I power it up. So it is on, and as you can see, if I just vary this rheostat, the voltage is varying, and along with it the current is also varying, but there is a bit of flickering over here because of this problematic rheostat. Though you can see as I am varying the voltage, see, just a second. Okay, here I am again going through the variation of voltage, and here, okay, I'm sorry, there is a problem. Yeah, no, it's okay. Okay, so again from the beginning, so I am just increasing the voltage, and you can see the current is also increasing. Okay, so if you just note some values of this potential difference here, if you just note, suppose if I just take a reading of this, and here the voltage is like 0.5 volts, and over here the value of current is like a bit less than 50 milliampere. So if you just note the values and make a graph with taking multiple values, then we can easily plot the graph here, and then we can just check the variation, and if it is a straight line, then obviously Ohm's law is valid for this instrument. and for this particular resistance, obviously. So if it is a non-ohmic substance, if this resistance is made of some non-ohmic substance, so in that case the variation will not be linear. Okay, so I believe that you have learned this in theory. So if it is a non-ohmic substance, if it is made of some non-ohmic substance, so the variation will be non-linear. So actually we have a kit over here, so it actually explains how Ohm's law is works. I mean how Ohm's law works, and by this kit we can just check the variation of current versus potential difference through a resistance. That is the verification of Ohm's law.